This will be a short video that discusses a nice little property of the Laplace transform called the S-shift rule. This is going to allow us to figure out the Laplace transforms of some additional functions very easily. And it works this way. Suppose you have a function y of t and you know its Laplace transform, capital Y of s. Okay, so now if you take your y of t and multiply it by an exponential, e to the at, a can be anything here. How will the multiplication of the e to the at change the Laplace transform? And the rule says that what ends up happening is it's just the same formula except shift it to the right by a. So just a reminder, this notation means same formula, but everywhere you see an s, replace it with s minus a. And if you remember some sort of pre-calculus, some basics about functions, replacing s with s minus a in terms of the graph, it just shifts the graph to the right by a. If a is negative, so that you really are doing s plus a number, that would be a shift to the left. Okay, so that means we don't have to go to the drawing board to figure out the Laplace transform when we multiply by an exponential, as long as we know what the Laplace transform was before we multiplied by the exponential. So that's the idea. So as an example, since we know that the Laplace transform of let's say cosine 4t, right? We know that that is s over s squared plus omega squared, but omega here is 4, so 16. Then without any real additional work, we would know that the Laplace transform of e to the, let's say, 7t times cosine 4t would just be s minus 7 over s minus 7 squared plus 16. Just replacing the s with an s minus 7. It's really the function of the same behavior, only shift it to the right by 7. Right. Similarly, if we know that the Laplace transform of t cubed is 6 over s to the 4th, right? Using the Laplace transform power function rule, 3 factorial over, and then 1 more power, 3 plus 1 is 4. So then if we wanted to do, let's say, the Laplace transform of t cubed times e to the minus t, let's say. So we're just multiplying a known one by an exponential. So it's going to be the same one, only now instead of s, we're going to have s. Now, my a here is negative 1, so minus a negative 1, so plus 1 to the 4th. So this is how it works, and this can be a nice help. One other thing that I want to point out is that, and this is not new information, but we already knew that the Laplace transform of 1 was 1 over s, and that the Laplace transform of just an exponential, which we figured out by going back to first principles, is 1 over s minus a. We had worked that out. Well, it turns out that really we could have gotten this second one from the first one, because e to the at is really e to the at times 1, right? And so the shift rule would say that the Laplace transform should just be a shift of 1's Laplace transform. And you see it is. It's exactly that. So these two rules go well. They match what the S-shift rule suggests the answer should be. I'm going to end this video with just a really quick explanation of why the rule works. Suppose that we know the Laplace transform of little y of t, and it is capital Y of s. So capital Y of s is, here's the definition of the Laplace transform, right? The integral from 0 to infinity of little y times the exponential. Okay, now let's see if we can figure out the Laplace transform of e to the at, y of t. Well, it would be the integral from 0 to infinity of our function times e to the minus st. Right? And a sort of semi-obvious thing to do, we have two exponentials, e to the at and e to the minus st. We can combine them. Right? So that'll be e to the a minus st. At minus st, and then I factor out a t up in the exponent. All right. And then just one more quick little adjustment. Instead of a minus s, I'm going to pull out a negative sign and write it as s minus a. Okay. And then the idea is compare that with this. And you see that everything is the same except in place of s, we have s minus a. It's the only difference. And so when there's an s in there, we're calling that capital Y of s. Well, when there's an s minus a in that same slot, that would be capital Y of s minus a. And so that is a complete proof of the S-shift rule.